what we look at today is a special type of sequence. Actually, we call it a series. So if 3, 5, 7, 9 is an arithmetic sequence, 3 plus 5 plus 7 plus 9 plus 11 is called an arithmetic series. The difference between a series, you are adding. So you're calculating the sum of the sequence. That's what a series is. So the symbol S of n is used to determine or to represent the sum of the n terms. So in this above example, the S of 5 would be equal to how much? So what is the sum of these 5 terms? 35. Asking or you telling? So there's a story that goes with this precocious little boy named Carl Gauss, who was actually grew up to be a very great mathematician. So the story is this. Little Carl is in class and the teacher has a whole bunch of stuff to do, so the teacher just gives him a whole bunch of seat work, thinking this will keep them busy. So her question is, I want you to add all the numbers from 1 to 100. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 all the way up to 100 and tell me what the total is. Figuring this is going to take them like a lot of time. Carl's done in like 10 minutes. Teacher, or I guess the teacher's a male, Master Butner is like, no, you're not done. Prove it to me. What's your answer? And Carl says the answer is 5,050. Teacher's like, okay, that's what it is, but now what am I going to do for the next half hour because you've already told the answer to everybody. So the question is, how did he figure it out so quickly? Well, this is what Carl did. Carl figured out that if I add from 1 to 100 going from 1 to 100, and then I go backwards from 1 to 100, I get all of these sums of 101. Every time I add them together, I get 101. How many of these 101s would I get? How many numbers am I adding from 1 to 100? 100 numbers. So I'd have 100 sets of 101, which would be 10,100. This 2, these are adding 2 of the sums. So 2 of those sums is equal to 10,100. So 1 of those sums would be half the amount. And there's my 5,050. This is how we put together the sum of an arithmetic series. We take the sequence and we basically flip it and add groups to each other. So we take the first term and the last term, start adding them together and going and working inwards. We're going to get the same sum each time. So in an arithmetic sequence, the first term is A. The second term I get is I add A plus 1 common difference. The third term would be 2 common differences. The fourth term would be 3 common differences, and so on. Until I get to that last, or t of nth term, where it'd be A plus n minus 1 minus d. So if I took the sum and I went from the lowest number to the highest number, my sequence would look like this. First term, which is A. Second term, A plus D. Third term, A plus 2D. All the way up. This is my last term, A plus n minus 1D. So the term before that would be my n minus 2. The third term before that would be my n minus 3. If I then reverse that sequence so that my nth term comes first and my first term comes last, then what I can start doing is I can start adding these terms. So if I add this term to this term, what I would get is 2a's plus n minus 1 times d. If I add the next 2 terms, what I get is a plus a, which is 2a, and then I have d and an n minus 1 or n minus 2d. When I put these together, I get n minus 1. And I can go through the algebra, or you can trust me on this. It would be n minus 1. And all the way through until I get to the last term, a plus a, which would be 2a, and n minus 1 times d. So I get the same thing each time, 2a plus n minus 1 times d. I would get however many of these as there are terms. If this is the t of 8 term, or the 8th term in the sequence, I would have a sum of 8. So I would have 8 of these groups. So in the previous question, Carl had 100. So I'd have 100 of these little groupings. If this is 2 of those sums, to get one of those sums, I would divide the whole thing by 2. And this becomes my formula. Again, you're not required to memorize the formula, you're required to use the formula. So what we are going to do is we are going to use the formula to answer some questions. The other thing that I can do too is in this formula, I can rearrange the formula. If need be, I could look at if I had the first term and the last term, which is what Carl did, 1 plus 100, and then he did 2 plus 99, 3 plus 98. So he took the first and the last term, multiplied it by however many groups he had, and divided by 2. So it depends what values I'm given. If I'm given the first and the last term and how many terms I have, I could use this formula. If I was given the common difference, but I was not given the nth term, then I would use the first formula. And you will need to know when it is appropriate to use either formula. So let's look at a couple of examples. First example is let's calculate the sum of the first 14 terms of this arithmetic series. So we have S of 8 would be my formula. So n would be equal to 8. So my formula is n times 2a plus 14. Oh yeah. I'm not sure where I got 8. There we go. I'm honestly not sure where 8 came from. So if I start using this formula, n times 2a plus n minus 1 times d. N is the number of terms in my series. How many terms in my series? 14. What is the first term of my series? 9. So I get 2 times 9 plus n is 14, so I get 14 minus 1. What's my common difference? How did you get 6, Bobby Ann?
I subtracted 9.
So 15 minus 9 gives me 6. 21 minus 15 also gives me 6. And then I would take that sum and divide it by 2. So if I was putting this in my calculator and I wanted to do it all in one step, I would need to start off with brackets. So I'd have to open a bracket up, 14, and then open another bracket up, 2 times 9 plus 13 times 6, and close that bracket twice. The first time I close it, it tells the calculator to do this calculation. The second time I close it, it tells the calculator to multiply it by 14. And then I can divide it by 2. And what would I get? There's another way that I could do this question. It's 14 terms. I could list the 14 terms and I could add them up. It's a lot of work. So look at class example. example number 2. Determine the sum of 22 terms of an arithmetic sequence where t of 1, or the first term, is negative 18, and t of 2, which would be the last term in a 22-term sequence, is 45. So if I look at my two formulas, if I know that the first term is negative 18, and the last term is 45. And how many terms are in the series? 22 terms. So I know that n is 22. Do I know what my common difference is? No. So is this going to be a good formula to use? Can I use this one? Because I have the first and the last. So that's the formula that we would choose to use. S of 22 equals n times a plus t of n divided by 2. So 22 terms times the first term plus the last term divided by 2. And tell me what you get. Okay, let's look at the third example. Find the sum of the terms in the sequence 17, 12, 7, all the way up to negative 38. So tell me what you know about this sequence, or this, yeah, what do you know about this sequence? I don't know how many terms I have, but what do I know? I know that the first term is 17, so that would be my t of n term, would be negative 38. Common difference, negative 5. So can I use either of my sum formulas at this point? Can I use either of those S of n formulas? Why not, Addison? I don't have n, and without n, I can't use the formulas. Is there a way I can figure out what n is? Without physically inputting all of the numbers from 17 to negative 38. I can use that first formula. That's my t of n formula. So t of n is my negative 38, a is my 17, n minus 1 is what I'm trying to calculate. So how would you solve this? What would you do first? Okay, remove the brackets, so then I get minus 5n plus 5. Next step. Okay, 17 and 5 equals 22.
But did you subtract 5 from 17?
No, because it's a plus 5. Because the negative 1 times negative 5 would give me a positive 5 when I expand.
Oh, I was thinking getting rid of.
They're on the same side. If I was getting rid of, if they were on opposite sides, then I would subtract. Now what? Okay, so take 22 away on both sides. Negative 38 minus 22 would be negative 60. Last thing, divide by negative 5. And what does n equal? N equals 12. Then I can find. Okay, so what did you get for a sum?
Oh, well, -1.6.
Negative, yep. Sorry, I was looking at the wrong question. Peter starts work at a salary of $16,000 per annum. He receives annual increases of $850, and he works for the firm for 12 years. I think this question's pretty dated because nobody works for $16,000 in a firm. That's not a very good job. So, calculate his salary in the 12th year. So that's calculating T of 12. So A plus N minus 1 times D. What's A? Say it louder, Rachel.
Is it the 16,000?
The 16,000 is what he started off with.
Because you started saying 9. I was like, no.
So what is N? 12 years. That's how many increments he's getting, or that's how many years he's worked for his increments. And what is his common difference? 850. That's how much money he gets extra each year. So in the 12th year, how much money did he get? $25,350. So that's his salary in the 12th year.
This guy's not Poor guy.
And then the next question, how much has he earned in a total of 12 years? So that would be S of 12. So do I need to use the first formula or the second formula? Or does it matter? Do I have enough information for both? Yeah. I could use either formula because the first formula takes this T of N formula and then throws in another A. So that's where I get the 2A plus N minus 1 times D. And then I multiply that by the number of terms and divide by 2. So I could use the first formula, or I could use the second formula, which is the N times A plus T of N divided by 2. 12 terms. First year was 16,000. The last year, or the 12th year, 25,350 divided by 2. What did you get, Jessica?
248,100.
Yes. So what I want you to do is I want you to practice these questions. 1AB, 2B, 3B, 4, and 6. And then I'll bring you back and we'll do some other questions. Okay. This last section. Corey was given 2 questions on a sequence and series assignment. The first question is listed below. Find the first 4 terms of the series defined by S of n. What does S stand for? Sum. So S of n equals 2n squared minus n. So complete her work below to find out what the first 4 terms are. So S of n equals 2n squared minus n. So if I calculate S of 1, I substitute 1 wherever I see an n. I get 2 times 1 squared minus 1, or 2 minus 1 equals 1. S of 1 means the sum of the first term. So T of 1 would be equal to S of 1, which means, therefore, that's what the 3 little dots signifies, therefore t of 1 equals 1. If I look at s of 2, that's the sum of the first two terms. I put a 2 in wherever I see an n, and I get 2 times 4, which is 8, minus 2 is 6. The sum of the first two terms is equal to the sum of the first term plus the second term. Or t of 2 equals the difference between the two sums. If I take 6 and I subtract 1, I get, what's 6 minus 1? 5. So if I look at this again, s of 3. S of 3 is the sum of the first three terms. T1 plus T2 plus T3. Well, T1 and T2 is s of 2. And if I add the third term, that would give me the sum of the three terms. Does that make sense? So s of 3 is adding the first term, the second term, and the third term. But these two terms right here, the sum of those two terms is the same as s of 2. And I know what s of 2 is. So if I calculate this out, I put 3 in for n, and I get 15. So t of 3, the third term, if I rearrange or isolate t3, it's subtracting s3 minus s2, which would be 15 minus 6, which is 9. What would t of 4 be? Say that louder, Bobby. How'd you get 13?
Because I know each number's a difference of 4.
Common difference of 4. I know now it's an arithmetic sequence. If I wanted to go through and do all the work, 2 times 4 squared minus 4 is 2 times 16, which is 32, minus 4 is 28. So the sum of the first 4 terms is the sum of the first 3 terms plus the 4th term. I can isolate that 4th term by finding the difference in the sum of the first 4 terms minus the sum of the first 3 terms, which would be 28 minus 15, which is 13. So if I was to express t of 10 in terms of s, kind of like what we did here. This is expressing t of 4 in terms of s. T of 4 equals s of 4 minus s of 3. What would t of 10 be?
T of 10, or s of 10 minus s of 9.
So it'd be the sum of the first 10 terms minus the sum of the first 9 terms. Does that make sense that the difference would leave you with the 10th term? Yeah, if I have a string of 10 terms, and then I have a string of 9 terms, and I subtract them, the thing that I'm going to be left with is that 10th term. So now if I had t of n, and I wanted to express that in terms of s, what would that be? S of n minus 1. 1 term less. I just don't know what that term is. It could be the 10th term, it could be the 20th term. The second question Corey received was find t of n if s of n equals 2n squared minus n. So in order to find the t of n formula, in order to use the formula to find t of n, I need to know what my first term is. What was my first term? And I needed to know what my common difference was, which is? So So then I would get 1 plus n minus d times 4. Remove the brackets. And then collect the like terms. Part 2 becomes a little bit more complex because we start to go into some heavier algebra. If we use this formula to find t of n, so find t of n if I have that formula. T of n equals s of n minus s of n minus 1. So this is s of n, 2n squared minus n. S of n minus 1, wherever I see an n, I would then put in an n minus 1 squared. Or not an n minus 1 squared, an n minus 1. So if I go down here, n minus 1 squared is n minus 1 times n minus 1. So if I expand this out, that's using the distributive property. It can be using my FOIL. N times n is n squared. My outside and inside terms give me 2 negative n's. And then my last terms give me a positive 1. So in my formula, I have 2 times n squared minus 2n plus 1. If I remove the brackets right here, I'm going to remove them by thinking of this as being a negative 1. Negative 1 times n is negative n. Negative 1 times negative 1 is positive 1. Multiply by 2. And then I'm going to simplify inside the brackets. Should be a minus there. Minus 2n squared minus 5n plus 3. So then if I remove these brackets, I will get 2n squared minus n. Think of this as being a negative 1. So I would change this into a negative 2n squared. This would become negative of a negative would be a positive 5n. And negative of the positive 3 would become a negative 3. Collect my like terms. The 2n squareds would cancel. The negative n and the positive 5n would give me 4n minus 3. I get the same result, which I should. This was easier to do, but only because I knew what the first term and the common difference was. If all I was working from was from this, I could use this method. Or I could go through and I could figure out the first term, the second term, and then be able to figure out my common difference and all of that. So it's just 2 ways to look at the same problem. So if we look at the class example. For a certain arithmetic series, S of n is equal to 1/2 n times 11 minus n. The question is, determine the first 4 terms. So to figure out the first term is always equal to S of 1. So I get 1/2 times 1 times 11 minus 1. So 11 minus 1 is? 10 times 1 is? 10 times 1/2 is? 5. Okay. To figure out the second term, it is the difference in the sum of the first two terms. So S of 2 minus S of 1, which I already know is 5. So what is 11 minus 2? 9. 9 times 2 is? Times 1/2 is?
Don't you have to subtract the 5 though? Or did you
Oh, no, I didn't. So 9 minus 5 is 4. What's T of 3?
S3 minus S2.
So 1/2 times 3 times 11 minus 3 minus S of 2, which was 9. So 11 minus 3 is 8. 8 times 3 is 24. 24 times 1/2 is, and 12 minus 9 is 3. What's T of 4? How'd you get 2, Jessica?
It's going down by 1 each time.
Going down by 1 each time. Because my common difference is -1. So questions 11 to 15 is what I'm adding. That's it.